Hello and welcome to a new lesson. We are continuing our work on the regular audit of SSH access logs task. If you recall, one of our subtasks is to update security measures based on what we found in the previous lesson, and that's what we are going to focus on today. Let's recall what we discovered in our previous lessons. So I will execute sudo cat /var/log/secure. Then I will search for the word failed inside the secure log using the grep-i command. From this output, we observed some failed attempts to log into SSH using the root user. Following best practices, we should prevent the root user from accessing SSH and disable password authentication for all users. Instead of using a username and a password for remote SSH access, we should adopt the use of public-private keys. Additionally, the system should be accessed by a user other than root, who should have sudo permissions like the user Rocky in our case study. Disabling password authentication will prevent brute force attacks, or in other words, render them ineffective. Now, let's explore how to prevent the root user from accessing SSH remotely, how to disable password authentication, and how to use public-private keys instead. So, let's edit the SSHD configuration file by typing sudo nano/etc ssh then sshd_config, and this is the main configuration file for SSH service on Red Hat family. Let's press enter and let's click Ctrl W to search inside the file, and I will search for permit root login, and I will uncomment this one and I will change it to be no. So by setting permit root login to no, this will prevent the root user from accessing SSH remotely. Let's save the file and let's restart the SSHD service to apply the changes. So I will type systemctl restart SSHD. I didn't get any error message, so this is a good sign that SSH service restarted successfully. To verify that, I will execute the same command, but this time I will type status. And as you can see from the result, the SSHD service is active and it's running since 23 seconds ago. Now to verify our new settings, I will connect from another terminal to this system. So let me bring the terminal here. So let's type SSH-p2224, then the root user at the IP of my Windows machine. Now let's press enter and I will copy the password from the Vagrant file, because if you still remember, Vagrant file changed the password for root to root password ! So I will copy this one and I will paste it here and press enter. After providing the root password, you will notice that I can't log in as the root user because we prevented user root from accessing the system remotely. Now let's test with the user test. So I will execute the same command, but instead of root, I will type test and I will copy the password of user test from the Vagrant file. Let's press enter and let's provide the password here. As you can see, the user test managed to access SSH remotely, while the root user didn't, because we set permit root login to no, disabling SSH access for the root user. Let me exit the system. Now let's disable password authentication. But first, we will generate a public-private key for the user Rocky. And also, we don't have user Rocky on the system, so let's create the user together. To create a user, I will type sudo user add, then Rocky. Now press enter. Let's set a password for user Rocky. So I will type sudo password rookie, then press enter. I will provide my password, then I will retype the password again. Now we have set a password for user rookie. Now let's create a public private key. So from my local machine, I will type SSH key gen to generate a public private key, and I will define the path to this public and private key to be in /home/turkey/.ssh/lab2. The SSH-keygen asks me to enter a passphrase. As a best practice, or to follow the best practice, you should provide a passphrase here to be as your password when you will access any system using your private public key. But for this lesson, I will not provide any passphrase. So I will just type enter, and I will type enter again. It seems that I didn't provide the correct path to the command because I added here a bracket to the path. So let's execute the command again, but this time I will ensure that I will copy the path only. So the key will be saved to /home/turkey/.ssh/lab2. Let's press enter and press enter again. And as you can see, my identification or the private key has been saved to the lab2 file, and my public key has been saved to lab2.pub. Now let's copy our public key to our lab2 virtual machine. So I will do cat here, then the path to the lab2.public key. Let's press enter, and here is the public key. Now let's go back to the lab2 virtual machine, and I will switch to user rookie, which we just created on the system. To switch to a user, I will use the su command, then dash, then the username rookie. Press enter, and now provide the password for user rookie. Now I am logged in as user rookie, so let's create the .ssh directory. And let's create inside this directory the authorized _keys file. Let's go back to my local machine, and I will copy the public key, which I just created with the private key, and let's add it here. Let's save the file. Okay, now let's test connecting to lab2 virtual machine using the private key we just created. To do so, I will type SSH-I, then /home/turkey/.ssh/lab2, which is our private key, then rookie at 192.168.0.223, which is my Windows machine IP. And because like I did the port forwarding, so I will add here SSH-B 2224. Now let's press enter. And as you can see, I managed to connect it to lab2 virtual machine using the public private key we just created. So I don't need a password to connect to lab2 virtual machine. Let's exit here. And now we are ready to disable the password authentication by editing the sshd_config file. So let's exit, and let's type sudo nano /etc ssh, then sshd_config. Let's click Ctrl W, and let's search for password authentication. And as you can see here, the password authentication is set to be yes, which means that I can access this system using username and password. To disable the password, I will set this to be no. Now let's save the file, and let's restart the SSHD service to apply our changes. So I will type sudo systemctl restart SSHD. I didn't get any error message, which is a good sign that SSHD service has been restarted successfully. To verify our work, I will try to access SSH using a password for the user Rocky from another terminal. So let's open the terminal and I will provide the SSH Rocky at 192.168.0.223, then -p2224. Now press enter, and as you can see, it didn't ask me for a password because I can't access it with a password because we have disabled password authentication in the SSH configuration. Now let's verify that we can access the system using the private key. So let's provide the SSH -p2224, then -i, and the path to the private key, then user Rocky at 192.168.0.223. Now press enter. As expected, the private key method works. Through this, we have learned together how to prevent the root user from accessing SSH remotely and how to disable password authentication for SSH. There are other measures you can take to secure SSH. One of these is to restrict access to SSH port to a specific IP, which could be your VPN IP. As we saw in our previous lessons on VPN, one of the use cases of a VPN is to restrict access to services. You can configure your firewall or security group to restrict access to SSH port from a VPN IP, a static IP, or your internal network IP range. That brings us to the end of this lesson. Thank you for watching and see you in next lesson.